Now let's see the question number 3. Why is the following situation impossible? A softball pitcher has a strange technique. She begins with her hand at rest at the highest point. She can reach and then quickly rotate her arm backwards so that the ball moves through the half circle path. She releases the ball when her hand reaches the bottom of the path. The pitcher maintains a component of force on the 0.180 kilogram ball of constant magnitude 12.0 Newton in the direction of motion around the complete path. As the ball arrives at the bottom of the path, it leaves her hand with a speed of 25.0 meters per second. First, let we assume that the length of her arm is R. Her arm of the arm is R. So the situation will be like this, that first the ball is at distance R, and from the with her shoulder, and we may say this is the center of the rotation, and then she rotates her arm to the lowest point and release the ball with a velocity of 25.0 meters per second here. And during this time, she maintained the force, a component of the force F equal to the 12 Newton all the time. So we have force F here, which the magnitude are all equal to the 12 Newton. So from this situation, you can see that we can use the work energy theorem to solve this problem. We have that the work from the force F is equal to the change of the kinetic energy and plus change of potential energy. The work of force F is equal to the F times the distance of the path, the total distance of the path. You can see that since force F is a tangential force, it means that it will parallel to the direction of the motion of parallel to the direction of the motion all time. So we can the work done is just the product of the force and the total distance. This distance. Okay, and since it is a half circle, so we have the distance equal to 2 pi r, half of 2 pi r. Okay, and this must be equal to the change of the kinetic energy, which of course 1 over 2 of mv squared, since v is equal to 0 here. So the change of kinetic energy is the final kinetic energy plus the change of the potential energy. In this case, we have the minus of mg2r. Here we use this point as the reference point, which means h equal to 0 here, and the initial height here, h is equal to 2r, right? So that's why we have this minus. Minus means that at the end, the potential energy is equal to 0, but initially we have the potential energy here equal to the mg of 2r, but the potential energy here is equal to 0. So the change of potential energy is minus mg2r. And we know everything except r here in this problem, so we will solve for the r. So we have that r of f pi plus mg twice of mg equal to the 1/2 of the mv square, right? If you move the second term on the right, if you move the second term on the right of this equation to the left and do some simple algebra, you can have this equation, right? And we have that r is equal to the half of the mv square over f pi plus 2mg, right? And once you enter the numerical value, we have that m is equal to the 0.18 0 kilogram. We have that v is equal to the 25.0 meter per second, and f is equal to the 12.0 Newton, and we use g here is 9.8 meter per second square. We will have that r is equal to 1.36 meter. So imagine a woman with a 1.36 meter long arm. This unlikely, right? This is unlikely for a woman or even a man to have a 1.36 meter long arm. So that's why we may expect that this is impossible. It means that if you want to have this situation, you must have the arm that is 1.36 meter long.